In this video, we're going to have a look at solving equations involving fractions. These usually come up at National 5 level. Technically regarded like an A-B sort of question. All of these questions have been taken from national5maths.co.uk. We've got 4 examples altogether. 2 are past paper questions. So solve algebraically the equation 2x minus 3x minus 1 over 4 is equal to 4. Before we go ahead and solve this, we should be comfortable with solving problems such as this, where you add 1 to both sides, divide both sides by 7, and dealing with any brackets. But what we're going to look at with these problems is all of these problems are going to involve a fraction. And we've seen in the past that when we've been dealing with solving equations, as long as we do the same thing to both sides, our equation will be balanced. So see, because we've got this 4 here, this problem would be much easier if that fraction were not there. So we can make this problem easier if we multiply everything by 4. So I'm going to multiply this by 4, I'm going to multiply this by 4, and I'm going to multiply this by 4. I do that because this 4 and this 4 would simplify to 1. So let's have a look. We're going to have 4 times 2x, that's 8x. And that's minus 3x minus 1, and that is equal to 16. From there we can just go ahead and solve. That's going to be 8x minus 3x plus 1 equals 16. Just multiplied out that bracket. That's going to be 5x plus 1 is 16. Subtracting 1 from both sides. 5x is equal to 15. Dividing by 5 is going to give us x equals 3. I'm maybe going to show this first step a bit differently once again. So what we said there is that we've multiplied both sides by 4. So technically what we've done is we multiplied the left by 4 and the right by 4. We did the same to both sides. So we did 4 times 2x, which was 8x. And then we did 4 times this, that's minus 4 lots of 3x minus 1 over 4 is equal to 16. And then we can see here that we had that simplification of the 4's. So that gave us our 8x minus 3x minus 1 is equal to 16. Okay, so we tried to kind of condense that into one line of working, but if you need to do it and show your steps a wee bit more clearly, no problem at all. Example 1, if we have a look at example 2, solve algebraically the equation x over 2 minus x plus 1 over 3 is equal to 4. This problem, you can see, has 2 fractions, x over 2 and x over 3. So what we're going to do is we're going to multiply each side of our equal sign by the lowest common multiple of 2 and 3. Okay, so the smallest thing in each times table is 6. So what we're going to do is we're going to multiply this side by 6. 1 wee second. Okay, apologies for that. We're going to multiply both sides by 6. I'm going to multiply this by 6. I'm going to multiply this by 6. So I'm going to get 6x over 2 minus 6x plus 1 over 3 equals 24. And then from there we can go ahead and simplify, because 2 goes into this once and into this 3 times, 3 goes into this once and into this 2 times. And that's going to give us 3x minus 2 bracket x plus 1 equals 24. We can multiply out that bracket, minus 2x minus 2 equals 24. We can collect like terms, we're going to get x minus 2 is 24. Adding 2 is going to give us x is equal to 26. Okay, so once again, you could have potentially went straight from here to here. Okay, I just showed these extra steps here. So we multiply by the lowest common multiple of the denominators, and we multiply both sides by that. Because if we're multiplying this by 6, we're halving it, which is 3. If we're multiplying this by 6, we're thirding it, and that's going to give us our 2 here. Okay, so those are 2 questions taken from national5maths.co.uk. 2 final problems that were taken from 2 past paper questions. Okay, so here's another problem taken from a past paper where we've got 2 fractions. So we want to multiply both sides of the equation by the lowest common multiple of 3 and 6. So the lowest common multiple of 3 and 6 is 6. So I'm going to multiply this side by 6. I'm going to multiply this side by 6. Multiplying this through, I'm going to get 12x over 3. Well, that's 4x. Multiplying this by 6, I'm going to get minus 30 over 6, which is 5. And that is equal to 12x. I want to solve this. A few ways to do this. I'll take my 12x over to this side. I'm going to get minus 8x minus 5 equals 0. We'll add 5 to both sides. Minus 8x equals 5. We'll divide by negative 8. 5 can't be divided by 8, so we just write it as a fraction. 5/8. But we've got a positive divided by a negative, so it's negative 5/8. And finally, solve the equation x over 2 minus 1 is equal to x, 3 minus x over 5. So once again, we've got a couple of fractions involved here. I'm just going to rewrite this. So we've got x over 2 minus 1 is equal to 3 minus x over 5. So we're wanting to multiply both sides of our equation by the lowest common multiple of 2 and 5. Lowest common multiple of 2 and 5 is 10. So we're going to multiply this side by 10. I'm going to multiply this side by 10. And as long as I do the same thing to both sides, the equation will be balanced. So I'm going to get 10 times x over 2. So that's going to be 10x over 2, which is 5x. 10 times minus 1, minus 10. Then I've got 10 multiplied by 3 minus x over 5. Now if we think about this here, this 10 and this 5 would simplify as follows. So we're going to get 2 lots of 3 minus x over 1. And we're not going to write over 1 because it's just what we've got. Then from here we can go ahead and solve. 5x minus 10 is equal to 6 minus 2x. We can add 2x to both sides. We've got 7x minus 10 is equal to 6. Adding 10 to both sides is going to give us 7x equals 16. And we can divide throughout by 7. And we'll get x is equal to 16 sevenths. Okay, that's probably what would be regarded as a hard solving equations question at National 5 level. But if you employ this strategy, it should hopefully work through okay. Thank you very much for your time.